Dear students, colleagues and followers, in video number 570 I used one sample t-test to compare the sample mean and the population mean. Sometimes we need to compare means of two independent groups, and the formula used for comparing the means of two independent groups is known as independent sample t-test. And in order to use this formula, let me explain. This is the formula for independent sample t-test, where the numerator is the difference between the sample means of two independent groups. And the numerator seems a little bit difficult, but let me explain this for you. The independence samples t-test formula looks very complicated, but it is meant to tell us something that is very simple. The obtained t-value tell us how many standard errors apart the two group means are. For example, if the two groups means one group has studied science in high school and the other group has studied humanities in their high school, and we want to compare their average marks in statistical analysis and social sciences, then this computed t-value will tell us how many standard errors apart are the two group means. It does this by taking the difference in the sample means and dividing it by the standard error. The difference in the means is calculated in the numerator of the formula, and the pooled standard error is calculated in the numerator. So this is the difference between the two independent group means, and this is the pooled standard error. The standard error used is known as the pooled standard error because it is calculated by putting information from both the groups together, and this is also known as pooling information. Therefore, we can understand the formula's main construction and outcomes as follows. The formula contains 6 symbols which represent and thus must be replaced with specific values. The independent sample t-test formula is as follows, that you see here. The numerator asks for the mean of group 1 and the mean of group 2. These will be used to calculate the difference in means. The denominator asks for the sample size of group 1 and sample size of group 2 and variance of group 1 and the variance of group 2. And these are evident here in this formula. These four things will be used to calculate the pooled standard error. Therefore, the formula requires we know three basic things about each of the two groups so that we can plug them in and solve this formula, that is mean, variance and the sample size. In order to compute the difference between the means of the two independent groups, let me go to my data file, and the data file is the same that I have been using for the last couple of videos. And since we are dealing with the quantitative data, and let me tell you, I'll be using the same variable, that is marks in statistical analysis and social sciences, and I want to compare means of two independent groups. So one group is those who studied science in high school, and the code for that is 1, and another group is composed of those who studied humanities in their high school, and they are coded as 0. So we will be comparing the mean or the average marks of those who studied science in their high school and the average marks of those who studied humanities in their high school. So this is the essence, and now let me go to analyze and compare means, but this time I'm not using one sample t-test, I'll be using independent sample t-test. So I'll click on this. I have already sent this variable, and this is the group. So let me do it for you again. I'm using to send or scoot marks in statistical analysis and social sciences before training to this place, that is test variables, and I want to use science versus humanities as a grouping variable. So I will define this. So these are the values. One is for science and 0 is for humanities. So I'll click on continue and then click OK. So here is my analysis of independent sample t-test. So Beginning with this table 1, this gives us the group statistics. Since I am comparing the means of two different groups, one is the group that is science in high school, that is those students who studied science in high school and those students who studied humanities in high school. The number of those who studied science is 60 and the number of those who studied humanities is 50. The average marks of those who studied science in high school is 57.57 and the average marks of those who studied humanities in high school is 49.14. These are their standard deviations and these are the standard error of means. And in this diagram, in this table, we have measured the difference between these two group means, and this we can do with the help of Levene's test for equality of variances. So there are two things: either we assume equal variances or equal variance is not assumed. So to test equal variance is assumed, this is the computed value of the F statistic and this is significant. So the null hypothesis of no difference between the two variances of the two group is rejected because this p-value is less than 0.05, so we use this one. So there are two t-test values of the independent sample t-test, so we will not be using this one because we reject the null hypothesis of equal variances. So we use this equal variance is not assumed, and here the t state is 5.110 and the p-value, the two-tailed p-value for this is also 0.000, so this is highly significant. So it means that the difference between the two means, that is the mean of those who studied science in high school and those who studied humanities in high school, is statistically significant. Ladies and gentlemen, as I told you earlier, that although this formula of independent sample t-test looks very complicated, but this is straightforward and very simple, and using software like SPSS we can easily calculate the difference between the two means. And we also elaborated that this difference of means, that is 8.42, is highly statistically significant, which means that the difference between the two independent groups, that is those who studied science in high school and those who studied humanities in high school, is highly significant. This is very useful and informative, and even those who didn't didn't study statistics in their college, or they have very poor background in statistical sciences, so they could also do this with the help of softwares. They may do this in Excel, they may do it in SPSS that I just did it, and they may do it in Stata that I'll do in some other videos, and R programming language. So answer will be the same. Kindly share this video with your colleagues, with your students, and with your friends, so that they could also benefit from this, and share this video in various WhatsApp groups so that this could reach to the maximum possible number of